Folks, a minute or two to filter in. I have a lot of chairs to sit in here. I'll just stand. Bonjour. I'll leave it at that for practicing my French. I'm Alex. I'm one of the co-founders, CEO here at Snorkel AI, also on faculty, University of Washington, in the computer science department, where I get to work with some grad students still. And generally have been working for the last decade or so at Stanford, UW, and now Snorkel, the company, on all things having to do with AI data. So I'm going to try to go into a little bit about what we're seeing in terms of the actual foundry for building AI models and AI systems, especially agentic ones. And this will go into a little into the weeds. I'll try to leave it leave all of you with some high-level takeaways as well about the role that data plays, and how we actually get models built from the ground up, from pre-training to post-training to fine-tuning and evaluation. What I think that's going to look like in the future for custom agents in the enterprise. So, with that, we'll jump in. So I'll start by giving a 2-second overview of Snorkel. I do work for a company, so of course you're going to get a company pitch. Might as well get it out of the way up front, and give you a little bit of an anchor point of kind of where we're coming from, what we build, and I'll use it as a recurring example in terms of how we're trying to support what I'm talking about here. Although I'm going to try to stay away from talking about our product specifically, but very briefly, we build a tech platform for all of the data operations that go into building AI data. So generating, curating, labeling data, doing that in more automated or programmatic ways, but also putting humans in the loop, what we'll refer to as experts or subject matter experts, so they can annotate, review, provide input, which, as I'll come back to over the course of this brief talk, that's kind of the key input to AI systems. It's not just data sitting around in a data lake, it's data that is curated or directly coming from experts who know about the domain that you're trying to evaluate or tune your model, your agentic system in. And then on top of that, we both license development platforms for doing evaluation of agents and models, for doing development, post-training, reinforcement learning. We also offer end-to-end curated data sets, which is our expert data as a service offering, where we work with many of the leading LLM labs. So on the platform side, we'll talk about that a little bit. We work with companies ranging from 7 of the top 10 U.S. banks to folks on the federal side, U.S. State side. And then on the data as a service side, we're mostly providing this to foundation model developers, the leading labs and others who are tuning and evaluating models at scale. Awesome. So key point of view, I've now said agentic, and I'm going to say reinforcement learning. So those are two buzzwords to keep the talk going. What I want to leave you with is a view that even if you don't buy my phrasing here that data is the key tool, or data development, data labeling is the key toolkit for AI development, that you at least realize that it's an important one as we get into especially specialized high-value settings for models, for agents. And a little bit of depth, if you're interested in paying attention to those parts of the talk, about how that actually gets operationalized. So I'll start with a simple metaphor. This was one of the, if you can tell which slides I made versus our marketing team, this one took me a lot of work. A very, very extensive Google search for stock photos on exam taking. But I'll start with a basic metaphor. A lot of AI development today starts with evaluation. And I won't go into this in too much depth, but broadly speaking, as we're moving from an LLM that, or a model that makes a single prediction or takes in a prompt and gives us, kind of a direct response, to these agentic systems, it's a bit of an overloaded term, but, in this sense, I mean systems that take multiple steps, that might be doing reasoning, planning, might be using tools, might be having back and forth interactions with users, and that also, in the other sense of the word, are automating things more so than they're just assisting or co-piloting. The space and the importance of evaluation and covering all the edge cases and making sure that they're covered very, very well becomes all the more important. So I'll start by talking about evaluation. And if you think about what goes into evaluation, I'll try to be, a little bit less dull than some parts of this talk where I'll go into details and be a little provocative and say that I think most of the evaluation companies and approaches out there are completely missing the mark on the hard part around the data. So we have lots of tools for observability, et cetera. But I'll use, sometimes I'll say that's kind of like saying that you have a testing center to test your human, or in this case, test your agent, and offering a wonderful set of chairs and tables and red pens and an app where you can monitor your students' performance week over week. But no one bothered to write the test questions. No one actually defined a grading rubric. No one taught people how to actually grade the exam or how to teach the students afterwards. That's the intellectual and operational heart of actually getting AI models and agents to learn, and I'll try to make the point that it's all about data. So the rest of this, I'll go through 3 major ingredients that all have to do with data development or labeling to actually run that exam, to test and evaluate how your models or your agentic systems are doing, and also to improve them. Number 1, a data set of prompts or questions. Again, this is barely a metaphor. Think of this as building the set of questions on the qualifying exam that define the set of things you want your agent or model to know. Number 2, a set of rubrics. Many different words for this, but this is basically, again, barely a metaphor, the grading rubric. What defines a good response versus a bad response? And number 3, a set of verifiers or evaluators that can either manually or more automatically assess the performance of an LLM or an agentic system. And collectively, this defines what I'll call an evaluation benchmark. So these are the ingredients to actually run your model, your agent through an exam. And the other point that I'll make, which maybe a month ago would seem more provocative and now is seeming day by day more kind of mundane and obvious, but is that if you have these elements, if you can build a good evaluation benchmark, increasingly, this is going to be all that you're going to need to actually build specialized AI systems. And that has a lot to do with the exciting advent of reinforcement learning. Not a new concept at all, but we're seeing it really take off and become operationalized. And if you have these ingredients, and we'll talk more about this, you can, I think pretty soon, just press a button and get your model optimized to do well on these benchmarks. And we'll talk about some cool results there that we have from our team and also how that works a little bit in more depth. So that's the basics. And I'll jump in and give a little bit more depth to all of those. And I think there are a lot of folks who are very in the weeds here and want to get in the weeds, although I didn't really read all of the conference background, so I could be way off the mark, in which case folks are invited to take a nap during some of these parts. But let's jump in. Okay. Oh wait, I forgot. I had one more high-level phrase before jumping in. So one thing to keep in mind here, I was using the test metaphor, but as we move towards AI driving actual products in the workplace, in the enterprise, in consumer applications, I'd argue that eval benchmark I defined there with its component parts, that effectively is the new product requirements doc. That is the spec for AI products. So I'll note that a lot of pieces here are not technical or data science ones. I believe that building these pieces is going to be or has to be a union between product managers or whoever is kind of owning and defining the product, the business, the line of business stakeholders, et cetera, and AI or data science team members. This is one and the same in the world of AI as building your PRD, building your product spec. Okay, so let's jump in and go through and give a little bit of depth on what each of these look like. I'll share some examples of how we're supporting developing these, both for the LLM labs, building the foundational models that we're all using, and enterprises who are specializing, developing, evaluating them for specific use cases, and a little bit into some of the meat. Okay, so again, Agentic is a very, I'm sure it's a phrase you've never heard before, never had thousands of vendors pitch you with Agentic. back in Silicon Valley, if you don't say agentic as an AI CEO, several times a day, you're booted, you lose your visa. So I have to say it. It's a fine term, it's an old term, it's a bit overloaded. So sometimes agentic means automation versus co-piloting. Other times, I'll talk about this a little bit here, agentic means having multiple steps. So being able to take reasoning or planning steps, have persistent memory, use tools, maybe have turns back and forth with the user. All of these complexities are really fun when you're in the data business because you have to build data sets that reflect all of these complexities. And that's a lot of what we do at Snorkel. I'll give a little hint or a little bit of color there. So agentic systems might have kind of very complex interactions or kind of internal processes that involve tool selection, planning, parallelized execution, summary and aggregation for the user. They also may look like a simpler loop, but that involves lots of back and forth with the user, often called turns. Here I'll give a simple operational definition, which is you can still think of this, and here's where I'll defend my original ingredient slide, as having a prompt and a response, a test question and an answer. In this case, in this multi-step reasoning, tool use, agentic setting, you might think of this as the prompt being an initial question. Could you figure out what the deductible on this policy is? Can you plan a trip to Paris for me? Can you figure out what the dress code is for an AI summit in Paris so you don't overdress? Things like that are ostensibly useful. And potentially multiple steps, actions, reasoning steps, maybe even intermediate back and forth response and discussion with the user up to a point, and then a correct response. So basically a sequence of actions, that's what's given to the model, and then you have a response, which is what you want it to generate. So I'm kind of folding in all of the multiple steps into this definition. So here's where I'll talk a little bit about how you actually build data sets of those prompts and optionally the correct responses. In other words, how you build your exam questions for actually testing your agent or your model on what it needs to know. And I'll note briefly, sorry, I'm supposed to pitch Snorkel a little bit, but just for localization, this is largely the work we do in our expert data as a service offering. That's where we use our source, our network of expert contributors, we call them, along with our platform to build data sets for evaluation, post-training, both for the LLM labs and for enterprises who are looking to use external data to tune and evaluate their system. So I'll talk a little bit about this, and I'll talk about it in the context of some open data sets and leaderboards that we're in the process of releasing. In this case, I'll give a brief example of an insurance agentic data set that was just released on Hugging Face. So there's a leaderboard. You can check out how the different models perform. This was built to be a data set that is realistic but still challenging. So the leading LLMs perform roughly 60 to 80% accuracy with significant inefficiencies even in the most accurate or kind of technically correct responses. So this is a challenging data set actually if you're looking for optimal tool use. So basically avoiding highly inefficient routes to answer the question correctly. Only, I think the max score is about 35% correct. So it's a challenging benchmark. It's a realistic one. This was built through our expert data service offering with qualified underwriters and our technical team and platform. Many more that are up there, and they're also, we release open data sets along with them if you actually want to dig in and play around. I'll skip over this. But I'll give a sense of what goes into building a data set. And I'll go kind of quick here because I think we have about 5 more minutes. But basically, there's a lot of complexity when you're considering an agentic setting. Here we have an agentic setup. This is still simple compared to what an actual underwriter might do, although it was certified and authored to be realistic. Here we have an underwriter. They have a book of business. They have what's called an appetite matrix for different types of risk. They have a SQL database. They have a whole pile of dynamic kind of changing PDFs that give their underwriting guidelines and policies. I know nothing about insurance. Just giving a sense of the kinds of resources that are very enterprise and domain specific that an agent will call on. And here we're also mocking up a setting where, in addition to having to kind of use these resources or tools, the agent has to actually interact with an underwriter. So this is a multi-turn setup where it's a co-pilot. It's we're building and testing the system to kind of go back and forth with a human user. So in setting up and building a benchmark data set here, again, all of this is going to get distilled into those kind of test questions, those prompts, but it requires actually building in a full simulation environment, including in this case a simulated LLM underwriter, so we can test how the model goes back and forth. And that's again built with both these synthetic techniques and humans, in this case qualified underwriters from our expert network, through every step of both generating the examples and reviewing them. In this case, there's a lot of steps that go into building high quality data sets like this to make sure they're realistic. I'll note that if you believe in free energy machines, then maybe you think I'll just use an LLM to synthetically generate this and then I'll go and improve my LLM based on that. A little, I'm exaggerating a tiny bit, but basically the idea that you can just kind of push button generate data that is going to expose novel, unsaturated parts of your space and actually improve your model. For the technical folks in the crowd, I'll give a caveat of up to a potential regularization effect that obviously can't, just by that free energy machine principle, produce something that's novel. In other words, you can't just say, LLM, generate a bunch of good scenarios for insurance so I can go and tune you on it to make you better at that. The key part is how you inject experts into this loop that uses AI to speed it up, but that is using the expert knowledge and the setting. So here, generally we have an expert who's building a prompt, a realistic setting. This is the test question. What do we actually care about an underwriting co-pilot doing? I have no idea, and a base model doesn't quite know, and it's, again, very enterprise specific. So this is where you have to build custom data sets. We have multiple underwriters who are reviewing, having a back and forth process, and then having an adjudication, a final adjudication protocol with our team. All of this is sped up with what we call quality control models, little fine-tuned distilled models that are checking to see if the data is in adherence with our spec. This is basically just a data labeling operation. So in other words, a lot of different tools, techniques, humans, and AI elements go into building a data set that is sufficiently high quality in a setting like this. I'll skip over this since we're almost at time, but we do a lot around distributional control. In other words, it's not enough just to, I'll switch metaphors for a second. If you're building a good data set, and bear with me because I'm not a good cook, but at a very high level, it's not enough just to say we need more ingredients if you're looking to cook a specific meal. It's not enough to say we need more good ingredients. You need the right mixtures of ingredients. Exactly the same is true with data. And actually a lot of our latest research from our labs, University of Washington, Stanford, elsewhere, have been about the importance of optimizing data mixture. So I won't get to talk much about this, but I'll say when you're building a data set, it's not just enough to have it be realistic, to have it be checked, in this case by underwriters. You have to have the right distribution of topics that matter for your setting and your business. Okay, so I'm going to wrap up pretty quickly here. There's a second topic that is a big topic of discussion at the different frontier labs and many of our customers and partners right now, which is how you build rubrics or the kind of grading guidelines. There's a lot that goes into defining what the definition of good is. In other words, what is a good prompt that simulates an insurance underwriting or a finance or a mathematical reasoning setting? A lot of this is really just a way of doing product management. Like I said, this is not just an AI problem. This is most often coordinating with the teams who are actually defining what do they want their agent or LLM to be good at, and how do we codify that into a grading rubric? Just like you'd have the same discussion if you were designing a test for certifying students in some area. So a lot of very, very interesting meat there, but the takeaway that I'll try to leave you with is it's not enough just to have good data. The data has to be good for your setting, and that's a product management question that gets instantiated into what we call the rubrics. And finally, since I'm about at time, I'll note, and there's a lot more if you want to check out some of our recent webinars, on how you actually build automated and semi-automated approaches to test whether the LLM or agent is actually performing well in the setting. So we built a data set of questions, of test questions, or benchmark prompts. We built a rubric for defining what a good answer looks like. Now we need some automated ways, or semi-automated, to check if it's correct. Now, I'll briefly note that a lot of fun stuff of how we do that in our platform, but there are many techniques for doing this. You may have heard the phrase LLM as a judge. I'll leave you with a thought that LLM as a judge is the kind of off-the-shelf approach. The key is building specialized evaluators. If I can be a little bit more glib about it, LLM as a judge is kind of like saying, telling the students in our metaphor to just grade their own exams. The key to getting good performance is to build evaluators or verifiers that are very specialized and accurate, which again is a data labeling problem. The last thing I'll leave you with is I used reinforcement learning at the beginning to kind of sound like I was in vogue. I've got to give you 2 seconds of tidbits of what that actually looks like, and then I'll jump off. So basically, evaluators and the underlying data define the basic ingredients of RL. So if you're familiar with reinforcement learning, you need to ask some base questions. That's the benchmark prompt data set. And then you need a reward function or a verifier to say whether the model was correct or not and give a signal. Those are the same thing as those evaluators we talked about. So if you build that benchmark data set along with the automated evaluators, you have all of the ingredients for reinforcement learning. Reinforcement learning is a very old concept, but with modern kind of pre-trained models and frameworks, we're seeing it become more push button than ever. If you're interested, you can check out some results. A recent paper we did with collaborators at Stanford, DeepMind, and University of Wisconsin was on using what we call weak supervision or programmatic approaches to building those evaluators and then getting great reinforcement learning results. A lot of fancy terminology that is different from what I use, but the basic point is exactly what I said, which is if you build these evaluators and you do them in smarter, more programmatic ways, which is a lot of what we work on, you can get amazing results on reinforcement learning. And if you check out that insurance data set that I was using, you can also see some results, and we're releasing these model artifacts shortly on basically how a 7 billion parameter model, in this case we use Qwen, can beat GPT-4o and all the other models in the benchmark with a little bit of reinforcement learning using those evaluators that we built and the benchmark data set. So I'll leave you with this. In AI, the benchmark data set, meaning the prompts or the test questions, the grading rubric, and the ways that you do the evaluation, that is both the product spec, it's also the core set of ingredients that increasingly will be the totality of what you need to actually build agentic systems using reinforcement learning. And getting this evaluation benchmark together is really all about the data generation, curation, and labeling. Okay, thank you all so much. Hopefully that leaves you some things to think about. If you're interested, Snorkel folks will be floating around. And great to meet you all.